So this is problem 5-41, and this is working with annuities with different compounding frequencies. We have Janet Boyle intending to deposit $320 per year in a credit union for the next 10 years, and the credit union pays an annual interest rate of 8%. So financial institutions are pretty much always going to quote rates as an annual rate. They have to, but our amount or future value is going to depend greatly on how frequently the institution compounds the rate. So what we're going to do is look at, with the help of our financial calculator, the future value of Janet's deposits based on the number of compounds during the year in each scenario. So we have $320 that's being deposited in the first one just annually. So this is kind of what we're used to seeing without having to change any compounding periods. So $320 is deposited annually. So this is multiple deposits, so this is an annuity. So $320 would be our payment, not our present value. So if this was a one-time deposit, this would be a present value, but being that we're going to have multiple deposits that are of the same dollar amount, then this is a classic annuity problem. So $320 is going to be our payment. Now, we have a choice here. We can enter this as a negative number or a positive number. And if we enter it as a negative, the future value result is going to be a positive figure. If we enter payment as a positive, then the future value is going to be a negative. So it doesn't really matter. You're going to get the same figure. You just ignore essentially the plus or the minus. But what I like to do as a best practice is I like to enter the negative as the payment, or in problems with a present value, I enter it as a negative for the present value. The reason I do that is because I think about it as money going out of your pocket or out of your account to invest in an account or an investment that you'll receive the principal and interest back in the future. And the future figure is the amount that you're receiving back. So think of it just theoretically as money out of your pocket or out of your account to invest in something. So up front it's a negative, but you're getting that money with interest back in the future, and that will be a positive. So for payment, I will enter it as a negative. We have a interest rate of 8%, so 8i. We know that it's going to be for 10 years, so $320,000 a year for 10 years, so 10 is our N. And then we can just solve for future value. So we're going to compute the future value. So at the end of 10 years, our annual $320 deposits will accumulate to $4,635.70. Okay, so now what if instead of $320 deposited just one time a year, what if it's split up between two deposits? So what if $160 is deposited twice a year? What's going to be the future value that Janet will have at the end of 10 years? So what we do is we just need to change some of our inputs. So let's clear that line. And so 160 negative will be our new payment. So instead of $320, it's going to be $160 twice a year. So that'll be our new payment. Our interest rate was 8% for the year, but now since it's going to be twice a year deposits, or compounded semi-annually, they pay interest semi-annually, so that would be 4% every 6 months. So our I is now, instead of 8 for the year, it's 4 every 6 months. So it's going to be 4I. And then the number of periods, the number of compounding periods, instead of 10, because there's 10 years, it's actually going to be 20. So it's going to be 2 interest payments or 2 compounds a year for 10 years. So 2 times 10 is 20. So 20 is going to be our N. And then we will compute for future value. And we can see already that, as we should have expected, the future value is going to be more because there's more compounding periods. So there's interest being earned on top of interest at a faster rate because there's more compounding periods. So $4,764.49 with semi-annual compounding. Okay, And then likewise, if we look at quarterly compounding, we would do it much the same way. So $80 will be our new payment. So I'm going to do 80 negative as the payment. And we have an annual rate of 8% that is going to be compounded quarterly. So there's 4 quarters in a year. So 8 divided by 4 is 2. So 2 is our I. So that's 2% for each quarter. There's 4 quarters in a year, so 2 times 4 is 8. So that's how we come up with that's how we break down the 8% annual rate into a quarterly rate. All right, then for a number of periods, there's 10 years, but there's 4 quarters or 4 different compounds in the year. So 4 quarters in a year times 10 years is 40. So we need 40N. And then we compute our future value. And we come up with, again, as expected, a higher figure than the previous two, $4,832.16. Let's check that.